What's up, my peeps? And welcome to another power-packed Phillips podcast. Don't forget, please write down that your homework tonight is workbook page 40, numbers 1 through 4. Please write down that your homework tonight is workbook page 40, problems 1 through 4. Also, just a quick reminder, you will have your district quiz tomorrow. Don't let any of Mr. McGrath's classes beat us. TY. Alrighty, if you would take out a piece of graph paper, I'm going to ask that you draw a coordinate grid like you did yesterday. Go up to 10, right to 10, left to negative 10, and down to 10. When you're done, I'm going to ask that you staple the coordinate grid into your notes. Please pause this podcast. When you're done drawing your grid, you may start it back up. BRB, going to grab a cup of coffee. Please write your notes. This is lesson 4.5 again, using the Slope Intercept Form, Part 2. Please write your notes, lesson 4.5, part 2, working on the slope intercept form again. Remember, yesterday we said that the equation for the slope intercept form is y equals mx plus b. We said that the slope is always the number touching the variable x. Bears. The y-intercept is the number that is not touching the variable x. Bears. We said yesterday that there are several different ways that you can graph a linear equation. You can make yourself a t-chart. You can pick 3 numbers. You can substitute them in. Bears. Plug and chug. That's like using the walk behind or push lawnmower. We also said another way to graph a linear equation is to make a t-chart, put 0 question mark and question mark 0 in. This is the shortcut method. This is like the riding lawnmower. This would be useful when you're trying to find the intercepts. This is called the intercept method. Put in 0 for x, work the equation. Put in 0 for y, work the equation. That is the intercept method. And yesterday we said that the third way, or the new way, is like you rising out of bed and running to catch the bus. Officially, that's called the slope intercept form. But because the crazy math teacher doesn't have an elevator that goes all the way to the top floor, his elevator stops a couple floors short of the top floor. Instead of calling it the slope intercept form, the crazy math teacher is going to call it the rise out of bed and run to catch the bus method. Remember that slope is the number that touches the variable x. Y-intercept is the number that does not touch the variable x. So if you would, on your paper please, write the linear equation y equals 6 minus 3x. We are going to graph this linear equation using the slope intercept form or the rise out of bed and run to catch the bus method. Alrighty, remember that the slope touches the variable x. So right here, you should be able to see that negative 3 is the one touching the x. So on your paper, please write slope and write negative 3. Y-intercept is a number that does not touch the variable x. So first thing I notice is that 6, correct, 6 is a SPY. So the 6 does not touch the x. Our y-intercept is 6. For my visual people, if you want to put the plus here because he's a SPY, I have no problem with that. On your paper, write the y-intercept is 6 or plus 6. We said yesterday, step 1, plot the y-intercept first. This is where your house will be. So I'm going to go plot my y-intercept at positive 6. Guys, epic fail. This is not the y-intercept, this is the x-intercept. Don't channel your inner Chicago Cubs. So my y-intercept is at 6. So right there, y-intercept is at positive 6. Please put yourself a dot. This is where we're going to start. Step 2, start at your house and plot the slope. Well, remember we said that negative 3 was touching the x. We said that negative 3 is our slope. But we got a problem here. Whenever we're talking about slope, we have a rise and a run. A rise and a run. So if I asked you to make negative 3 a fraction, you would say, crazy math teacher. Put a fraction bar, and then hopefully you would say, crazy math teacher. Give it a denominator of 1. So to make negative 3 a fraction, give it a fraction bar, give it a denominator of 1. Now yesterday we went up, but today we're going to go down. The reason I'm going down when I do my rise is because 3 is a negative number. So if your rise is a negative number, you are going to go down. My denominator, I'm always going to go right. My denominator, I'm always going to go right. So I'm going to go down 3 because it's negative, right 1. So I'm going to start right here. I'm going to go down 3 and right 1. Put a dot. Rule of thumb, keep graphing until you pass the x-intercept. So for my visual people, keep graphing until you pass that blue highlighted line or that x-intercept. So I'm going to go down 3, right 1. I'm equal with it, but I'm not past it. Go again, you missed the bus. Down 3, right 1. Now, congratulations. You caught the bus. You can go to the crazy math teacher's class. Draw yourself a line with arrows on both ends, and your linear equation should look something like this. My y-intercept is where we started. My y-intercept is at 6 or positive 6. My x-intercept is right here at 2. Here is the line for my equation. Y equals 6 minus 3x. Remember, the crazy math teacher hates this slope. This is a negative slope. Well, if I go back and look at my problem, I did have a negative slope, so I know that somehow, some way, my graph has to go down and to the right. Alright guys, thanks for watching. We'll continue working on this. We've got a couple of different situations that we will do next time, but you should be able to get the hang of it. You're a smart group of kids. Alright, make sure this is stapled in your notes. See ya, wouldn't wanna be ya. Keep it real.